ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಆಲ್ರೆಡಿ ನಾವೇನು ಮಾಡಿದ್ವಿ ಅಂದರೆ ಕೆಮಿಕಲ್ ಇಕ್ವೇಷನ್ಸ್ ಆ್ಯಂಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಚಾಪ್ಟರ್ನ ಒಂದೇ ಕ್ಲಿಪ್ಪಲ್ಲಿ ಪೂರ್ತಿ ಏನಪ್ಪ ಅಂದರೆ ಅದರಲ್ಲಿ ಬರುವಂಥ ಹೈಲೈಟೆಡ್ ಪಾಯಿಂಟ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಈಗ ಏನಪ್ಪ ಅಂದರೆ ಚಾಪ್ಟರ್ 2 ಆ್ಯಸಿಡ್ ಬೇಸಸ್ ಆ್ಯಂಡ್ ಸಾಲ್ಟ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು. ನಾನು ಮೊದಲೇ ಹೇಳಿದ್ದೀನಿ, ಈಗ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಇವೆಲ್ಲ ಆಡಿಯೋ ನೋಟ್ಸು. ಒಂದು ಸಲ ನಿಮ್ಗೆ ಕೇಳಲಿಕ್ಕೆ ಹೆಲ್ಪ್ಫುಲ್ ಆಗಲಿ, ಕೇಳ್ತಾ ನೋಡಿದ್ರೆ ರಿವಿಷನ್ ಆಗ್ತದೋ ಅನ್ನುವಂಥ ದೃಷ್ಟಿಯಿಂದ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ ಇದರಲ್ಲಿ ಹೆಚ್ಚು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ನ ಕೊಡದೆ ಕೇವಲ ಆಡಿಯೋ ರೂಪದಲ್ಲಿ ನಿಮ್ಗೆ ಕೊಡುವಂಥ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹಾಗಾದರೆ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಆ್ಯಸಿಡ್ಸ್. ಓಕೆ, an acid is a substance that produces a hydrogen ions when placed in water. When acids or ionic compounds are dissolved in water, the ions split apart from each other. Okay, whenever they dissociate, what happens? They give ions. For example, hydrochloric acid gives a hydrogen ion, and chlorine ion whenever it is dissociate in a water or whenever it is dissolved in a water, both the ions are separated. Most acids are what? Taste sour, react, okay, with many metals to form hydrogen gas. Okay, with many metals to form hydrogen gas. Are corrosive, appear to eat away materials while reacting, have a chemical formula that begins with H. Okay, the most of the acids, they have a chemical formula begins with a H. Then here they given one reaction. What happens whenever the zinc, okay, zinc reacts with the hydrochloric acid? What it gives? It gives a zinc chloride with liberation of hydrogen gas. With liberation of a hydrogen gas means the acids reacts with a metal, they give a salt and they liberate a hydrogen gas. Then common acids. Okay, in the what are common acids? We classify them into strong acids and weak acids. So strong acids are hydrochloric acid, sulfuric acid, nitric acid. Hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. Then acetic acid. Acetic acid, it is also called as a ethanoic acid. Okay, acetic acid CH3COOH, its formula. Citric acid C6H8O7, citric acid. Formic acid HCOH, HCOOH. Then now we are going to discuss bases. A base is a substance that produce hydroxide ions. That produce what? Hydroxide ions when placed in water or whenever it is dissociated in water. When the base or ionic compounds are dissolved in water, the ion splits apart from each other after dissociation. For example, sodium hydroxide NaOH. In this NaOH, whenever they dissolve in water, what they give? They give sodium ions and hydroxide ions. Okay, the reaction is like this. See, NaOH whenever dissociate in water, what it gives? It gives sodium ions plus hydroxide ions. Okay, very simple reaction. Properties of bases. Most of a bases tastes bitter, feels slippery, are corrosive, appear to eat away materials while reacting, have a chemical formula that ends with a OH. Have a chemical formula that ends with a OH. Then now we are going to discuss common bases. Ammonia. Okay, it is used in cleaners and fertilizers. Then sodium hydroxide used in soaps and detergents, drain cleaners. Magnesium hydroxide ingredient found in antacid. For example, eno, gelusil, whatever we prepare antacid, in those antacid main ingredient is a magnesium hydroxide. The next one, indicator. Okay, indicators are used to determine if the substance is acid or base. An indicator changes specific color when in the presence of acid or base. Then litmus paper, it is also indicator made up of a special filter paper that contains a dyes extracted from what? Lichens. Okay, the crusty stuff that grows on rock. Okay, lichens are what? They are the indicators of environment cleanness. Okay, then a blue litmus paper turns red with acid. Red litmus paper turns blue with base. Okay, it's a very important. Types of indicators. Indicators showing a different colors in acid and base medium. Natural indicators are what? Litmus paper and red cabbage. Litmus paper and red cabbage. Synthetic indicators are which one? Phenolphthalein and methyl orange. Then indicates giving a different order in acidic and basic medium. Okay, those are detected with the help of our nose. In our nose, olfactory nerves are there. Those olfactory nerves are called an olfactory indicator. Okay, for example, onion and clove oil is detected with the help of olfactory what indicators. Reaction with metals, reaction of metals with acids and bases. For example, acids, what a strong acid or king of acid is a sulfuric acid. Okay, it reacts with the zinc. What it gives? It gives us zinc sulfate with liberation of hydrogen gas. Next, hydrochloric acid reacts with the metal zinc. What it gives? Zinc chloride with liberation of hydrogen gas. Then what bases? Bases not more reacts with the metals, but here one the example given. Okay, whenever the zinc reacts with the sodium hydroxide, it gives a sodium zincate. Sodium zincate NaZnO2 with the liberation of hydrogen gas. With liberation of what? Hydrogen gas. Reaction of acids and bases with metal carbonates and bicarbonates. Okay, whenever the acids reacts with a carbonate, for example sodium carbonate, what it gives? It gives a sodium chloride, water and carbon dioxide. Then whenever the acids reacts with a metal bicarbonate or what hydrogen carbonates, what it gives? It gives sodium chloride, water and again same products, carbon dioxide. Then test for a carbon dioxide. Test for a carbon. Here carbon dioxide is liberated. How we have to detect? We have to detect with the help of a small experiment. That experiment with which one? Lime water. Whenever we pass this carbon dioxide to lime water, okay, it forms insoluble in water. Which form? Calcium carbonate and water. Okay, it's what? Lime water. Next, calcium carbonate plus water plus carbon dioxide. It forms a soluble in water. What? Calcium bicarbonate. CaHCO3 twice. It's a calcium bicarbonate. Calcium carbonate reacts with water and excess of carbon dioxide. What it gives? It gives calcium bicarbonate, which is what? Soluble in water. And whatever here calcium carbonate plus water is found, it's insoluble in water. Reaction of acid with bases. Neutralization reaction means when an acid reacts with a base, it gives a salt and water. It is called as a neutralization reaction. For example, acid reacts with a base. Okay, if it gives a salt and water, it is called as a neutralization reaction. Then whenever the acid reacts with a base, it gives a salt and water, means it's a neutralization reaction. For example, sodium hydroxide reacts with a hydrochloric acid. What it gives? It gives a sodium chloride and water. Sulfuric acid what reacts with a sodium hydroxide. What it gives? It gives a sodium sulfate and water. It's also neutralization reaction. Reaction of a metallic oxides with acids. For example, aluminum oxide, okay, reacts with the hydrochloric acid. What it gives? It gives a aluminum chloride and water. This is also neutralization reaction, but here aluminum oxide is an amphoteric oxide. Why? Because sometimes it acts as a base, sometimes it acts as acid. It reacts with the acid also, it reacts with the base also. And what it gives? It gives always salt and water. That's why it is an amphoteric oxide. Same zinc oxide reacts with the hydrochloric acid. It gives a zinc sulfate and water. Okay, it is also amphoteric oxide. Why? Because it reacts with the acids also, it reacts with the base also. What it gives? It gives a salt and water. That's why it's a amphoteric oxide. Reaction of a non-metallic oxides with the base. Example, carbon dioxide reacts with the what? Calcium hydroxide. What it gives? It gives a calcium carbonate and water. Okay, this is the what? Non-metallic oxides reacting with base. Then now we are going to discuss about pH. The pH scale can also help us to classify solutions as acids and bases. The pH is a measure of the amount of hydrogen ions in a solution. Okay, pH long form potential hydrogen. The more hydrogen ions, what? Lower the pH, the more acidic the solution. And if less hydrogen ions, higher the pH, and what? It's a more basic solution. Then they given what, so some substances 0 to 7, 0 to 7, whatever the substances are there, those are acids. 7, it's a what? It's a what? What we call that, neutralized substance. And these are basic substance. These are what? Basic substance. Then our gastric juice, vinegar, tomatoes juice, or soft drinks all comes under acids. Then what, our body works in nearly 7: blood, plasma, milk, okay, baking soda, egg white, okay, these are all nearly, they are what, base are what, neutralized one. Milk of magnesia is a strong base, okay. Then drain cleaners, these are what, strong bases. When describing acid and bases, strength and concentration do not mean the same thing. Strength refers to ability of acid or base to dissociate in solution. pH measure this. Dissociation refers to the ability of an ionic compound to break apart into ions. Then concentration refers to the amount of acid or base dissolved in water. An acid or base will have the same pH regardless of how concentrated it is, just because you add a water to dilute it. It's still going to have the same amount of hydrogen ions, they will just be spread out more. Strong or weak acid and bases. When a strong acid base dissolves in water, nearly all of the acid or base molecules will dissociate into ions. The greater the ability to dissociate, the more potential the acid or base has for being dangerous, because what, there are more ions available to react. They are more available, but more ions available to react in where strong acid. Okay, for example, in strong acid, hydrogen ions are more are there. Then when weak acid or base dissolves in water, only a small fraction of the acid or base molecules dissociate partially with less ions. Which ions? Hydrogen ions in a solution. There is a less potential for a danger because there are less ions available to react. Strong acid examples. Strong acid, what acids? Hydrochloric acid, okay, it's a stomach acid. Sulfuric acid, battery acid. HNO3, nitric acid, we use in industries. Then weak acid, acetic acid, CH3COOH, okay. Then citric acid, C7 C6H8O7, okay, that's available in where, citrus fruits. Strong base, sodium hydroxide is a strong base. Any alkali or alkaline earth metal with more hydrogen ions, KOH, potassium hydroxide, it has a more hydroxide ions, then it is a strong base. Weak base, aluminum hydroxide often found in deodorants. Okay, aluminum hydroxide different and ammonium hydroxide is different. Ammonium hydroxide, ammonia used in many cleaning products. These are weak bases. Then neutralization. Neutralization is a chemical reaction between acid and base that takes place in a water solution. When acid and base react, the hydrogen ions form the acid to react with hydroxide ions to form the base to form a HOH, that's a water. HOH, that's a water. The overall pH becomes neutral. Then now we are going to discuss about salts. The ions that are left behind after the hydrogen and the hydroxide ions form water combined to form a salt. A salt is a compound that forms when the negative ions from the acid combine with the positive ions to the base. Acid HCl, base KOH, and water H2O, then salt KCl. Then chemicals from common salt. Okay, chemicals from common salt. So from sodium chloride, it's a common salt. From common salt, we prepare a sodium hydroxide, that is called as a caustic soda. Then we prepare a calcium oxychloride or calcium oxychloride. It's a what, bleaching powder. Then sodium hydrogen carbonate or sodium bicarbonate, it's a baking soda. Then next washing soda, sodium carbonate decahydrate. It's a washing soda. These all products are prepared with the help of common salts, which is available in sea or ocean. Then preparation in a chloralkali process. In a chloralkali tank, we take a what what chloride solution, that's also called as a brine solution. Okay, brine solution has a more amount of water. It undergo a electrolysis, and what it produces a sodium hydroxide with liberation of hydrogen gas and with liberation of chlorine gas. Both not all these three products are useful in what very very useful in industries. It is called as a chloralkali process or electrolysis of brine solution. Then uses of sodium hydroxide. Sodium hydroxide is used in soaps and detergent, in the preparation of soaps and detergents. It is used in the preparation of a paper industry as a laundry agent to clean our clothes. We use as it laundry agent or laboratory reagent. We also use sodium hydroxide as a laboratory reagent. Okay, in whenever we are preparing calcium oxychloride, calcium oxychloride. Okay, to prepare that calcium oxychloride we need a chlorine, and chlorine, it is available in chloralkali process. That's why what sodium hydroxide, chlorine, and what another one product, which one, hydrogen. These are the byproducts of chloralkali products. Uses of a chlorine as a disinfectant. Chlorine is used as a disinfectant, making a PVC, polyvinyl chloride polymers. Okay, this chlorine is also used in what CFC, chlorofluorocarbon. Okay, it is also used in DDT, diphenyl trichloroethane. Then uses of a hydrogen. Okay, to prepare a vegetable oil, artificial vegetable oil. Okay, uh, by additional reaction we use a hydrogen there. And hydrogen is nowadays a what biggest source of a fuel, because what nowadays what all scientists, they are engaged in preparing a hydrogen oriented what cars or bullet trains, all these things. Preparation: bleaching powder, chemical name calcium oxychloride. Okay, calcium hydroxide, it's a lime water passed with the chlorine gas. What we get a calcium oxychloride, that's bleaching powder with water. Then uses of a bleaching powder. Okay, bleaching powder used in textile industry for bleaching cotton and linen to give a shiny white surface. We use a bleaching powder. Paper industry for bleaching wood pulp, because wood pulp is in what brown color. To make it white, what we use a bleaching powder. As a disinfectant to kill whatever the microorganism present in sand and sewage water. Okay, we use a chlorine, what bleaching powder. Then preparation of sodium hydrogen carbonate. Sodium hydrogen carbonate, it's a baking soda. Okay, in sea, what salt water is available. That's why sodium chloride, water, ammonia, and carbon dioxide. All these are what combining. What we get sodium hydrogen carbonate with ammonium chloride. Okay, like this we prepare a sodium hydrogen carbonate. Then sodium hydrogen carbonate is also called as a baking soda. Uses of a baking soda as an antacid against acidity. In a soda acid, fire extinguishers. Along with the edible acids like tartaric acid, it is used for making breads and cakes soft, spongy. Okay. On heating, sodium hydrogen carbonate, what it gives? It gives a sodium carbonate, that's a washing soda, and a small amount of water with liberation of carbon dioxide. This carbon dioxide only makes what? Bread spongy and soft. Washing soda, Na2CO3. Washing soda, sodium carbonate decahydrate. Sodium carbonate decahydrate prepared by a recrystallization of sodium carbonate. Then sodium carbonate what passed to water. What it turns, it carbon what turns into sodium carbonate decahydrate, uses as a cleaning agent in domestic purpose, to clean our clothes, to clean utensils we use. In the manufacture of glass, soap, borax, and papers, we use a sodium carbonate decahydrate for removing permanent hardness. Okay, to make it what hard water into soft water, what we use a sodium carbonate. Water of crystallization. Water of crystallization is the what fixed number of water molecules chemically attached to each formula unit of salt in its crystalline form. Example, blue colored copper sulfate crystals Cu SO4 into 2H2O. Okay, copper sulfate crystals formula. Green colored ferrous sulfate crystals. Okay, ferrous sulfate Fe3O4 into 3H2O crystals. Plaster of Paris. Plaster of Paris CaSO4 into half H2O. Calcium sulfate hemihydrate. Okay, two calcium sulfate units share one molecule of water. One molecule of water. It is prepared by heating gypsum calcium sulfate dihydrate. It becomes hard on contact with the moisture. See, calcium sulfate dihydrate, whenever we heat, what we get a calcium sulfate hemihydrate and one and a half H2O. Okay, this is called as a POP, plaster of Paris. For making decorative items, toys, making surface smooth, supporting fractured bones, what we use a plaster of Paris. Okay, these are the what very very important key points related to acids, base and salts. Okay, again same dialogue. Which dialogue? ನಿಮಗೆ ಉಪಯುಕ್ತ ಅನ್ನಿಸಿದ್ರೆ ಹೌದಾ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಶೇರ್ ಮಾಡಿರಿ. ಆಮೇಲೆ ಬಹಳಷ್ಟು ಜನ ನನ್ನ ವೀಡಿಯೋಗಳನ್ನ ನೋಡ್ತಾ ಇದ್ದೀರಾ, ಆದರೆ ಅವರೆಲ್ಲ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ. ನಾನು ಮಾಡುವಂಥ ಪ್ರತಿಯೊಂದು ವೀಡಿಯೋ ಕನ್ನಡ ಮೀಡಿಯಮ್ದಾಗಿರ್ಬೋದು ಅಥವಾ ಇಂಗ್ಲೀಷ್ ಮೀಡಿಯಮ್ದಾಗಿರ್ಬೋದು ಅಥವಾ ಎನಿ ಸಬ್ಜೆಕ್ಟ್. ಓಕೆ, nowadays I'm not only going to prepare science, other subjects also, question paper solving or chapter wise question answer solving, like this I'm doing work. So if you want every videos notification, then subscribe. Thank you so much.